Both these questions are given in NEET 2017 and 2016, and both of them are based on Doppler effect of sound. That's from the chapter waves. I will solve chapter question one by one. Let's have a first question. Two cars moving in opposite directions approach each other with a speed of 22 and 16.5 meter respectively. So let us draw that path. What is the meaning of that? How do you visualize that? Let me try to show. Yeah. So this is car 1, this is car 2 approaching each other. One with a velocity of 22 meter per second, another with a velocity of 16.5 meter per second. It is further said, the driver of the first car blows horn with a frequency of 400 Hz. So this is the first car. So it blows a horn with a frequency of 400 Hz. Thus it becomes the source who is making the sound. So that velocity becomes velocity of the source itself, right? What is the frequency heard by the observer? So this person becomes automatically observer. This is the original frequency. What is the apparent frequency heard by the observer is the question, where velocity of sound is 340 meter per second. So the first thing that you need to understand is sound always moves from the source towards the observer. This is how the sound is going. So according to Doppler effect, apparent change in the frequency due to the relative motion of source and observer is called Doppler effect. So what's the equation for the apparent frequency is, here both source and observer are moving. So the natural equation is V plus R minus VO by V plus R minus Vs into N. Now when I have to put a plus, when I have to put a minus is the important question, right? Look at the observer. Observer is approaching the source. As the observer is approaching the source, because of the motion of the observer, apparent frequency will be more. So because of the observer, apparent frequency has to increase. If it has to increase, being the observer term is in numerator, I have to write a plus. Again, look at the source. The source is also approaching the observer. So the source is also doing in such a way that because of the motion of the source also, apparent frequency increases. But look at the source term, that is in denominator. If something has to increase because of the source, that is in denominator, denominator has to reduce. Then I have to write V minus Vs into N. So this is the formula, right? I have explained this in detail in the other videos of Doppler effect. Please go through for the derivations if you don't know how to write a formula. I will now write velocity of sound is 340 plus velocity of the observer is 16.5 meter per second. The velocity of sound is 340 minus velocity of the source is 22 meter per second. So this becomes 356.5 by 318. Of course, into N is there, natural frequency, who is 400. So it's obvious that this value is definitely going to be more than 400 because numerator is more than the denominator, which is a multiple of 400. So I can definitely rule out these two options. They are definitely not there. 356 by 318 is not that small such that it becomes 411. So that is also not the right answer. The second answer is, if you calculate, you will get that much, 448 Hz. That's how you have to solve that first problem. Let's have a look at this second problem. It says, a siren emitting a sound of frequency 800 Hz moves away from the observer towards a cliff at a speed of 15 meter per second, right? So there is an observer. A siren is emitting a frequency of a natural frequency 800 Hz, moving with a speed of 15 meter per second, that is the velocity of the sound, towards a cliff. This is the cliff, like a wall. Then the frequency of the sound that is heard in the echo reflected from the cliff. So what happens is, this sound hits this wall, cliff, and then reflects back. With what velocity? With the same velocity of the sound itself, 15 meter per second. So this becomes the velocity of the source. approaching the observer, nothing mentioned about the velocity of the observer. So we have to assume that observer is in the state of rest. Again, the same formula like I have written earlier, V plus or minus VO by V plus or minus Vs into N. Here observer is in the state of rest. So V by V, between V plus or minus Vs, I have to choose the right term, plus or minus. But if you notice, source is approaching the observer. So as the source is approaching the observer, because of the motion of the source, apparent frequency has to increase. So if it has to increase, being it is in denominator has to be less. So I have to write V minus Vs into N. Now I can substitute the data, and dash equal to V is 330 in this problem by 330 minus source is 15 into apparent frequency. Original frequency is 800. So 330 by 315 into 800. So it's obvious that it is going to be more than 800, right? So these two options can be definitely ruled out, right? These two options can be definitely ruled out. So if you calculate this value, it becomes 838 H, not 885. It is too high. If you calculate, you will get 838 H, because 330 by 315 is little more than 1. So this is how we solve the Doppler effect problems. So in solving both these problems, we shall remember the Doppler effect. Doppler effect means the apparent change in the frequency due to the relative motion of source and observer. That's how you have to solve these problems, writing a basic formula. This formula, right? Thank you for watching.